Dr. Gold in the lab, Twitch stream glowing, formulas flashing, minds wide, knowledge flowing, equations on the board, numbers never sleep, teaching math and physics while them haters count sheep. Actual education, tune in and get schooled, flipping textbooks, breaking all the rules, from Newton to Einstein, concepts elevate. Keep the stream, it's the key to our fate. Dr. Gold dropping gems, knowledge raining down. Actual education making scholars all around. Perpendicular minds, angles sharp as ice. Maths and physics, yeah, the future's real nice. Got the Pythagorean triangles about to flex. Quantum theories on deck, breaking all the specs. Relativity theories, worlds getting small. Grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep. Grazing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold. Brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down. Actual education making scholars all around. Perpendicular minds, angles sharp as ice. Maths and physics, yeah, the future's real nice.
What's up, everybody? Awesome. Ooh, let's get the lo-fi beats going. Let me start this on here. There we go. Yes. There we go. There's that. Why do I have all these ads? Stop the ads. Let's get the lo-fi beats going, dude. What's up? It is Wednesday. I went and donated blood. That's why I have this on me. Yeah. First time I've ever done that. What's up, Aduki? Good to see you, dude. It's actually a very interesting experience. I almost fainted at the end. The person was like, "You look a little pale, dog." And so he had to put like cold towels on me and stuff. He's like, "You need to stay here for like 15 minutes." I was like,
no.
Okay, fine. Oh, now my arm is locking up. Oh, damn it. They got me at the gym. I was at the gym. I was doing a workout, and then I was leaving the gym. They're like, "Hey, you want to donate blood?" I was like, "Yeah, sure. Why not? Whatever. I'm here." But problem with donating blood is you start losing like iron and like nutrients, and especially if I've worked out. Now my arms are cramping. Oh, that's gonna be a pain in the ass. Anyways. Okay. Let's see what's going on today. It's the day before Thanksgiving. So some people have class, but I think a lot of people don't have class because tomorrow is a big American holiday where we eat a bunch of turkey. I think Canada also has like a Thanksgiving, but theirs is like a week earlier. I want to say. I think it is. Let me find it. When is Canadian Thanksgiving? Let's see. Ooh, Canadian Thanksgiving was last month. Oh wow, it was a very long time ago. And it was on Monday. Is it always on Monday? Oh, it's always held on the second Monday in October. That's pretty interesting. Because, like, I don't know. Yeah, Monday, that kind of sucks. Like, what? Excuse me? Like, the whole nice thing about Thanksgiving being on Thursday is then you're not really expected to work Friday, and then you get the weekend to, like, recover. If I had to, like, eat myself stupid on Monday and then go to work Tuesday...
No.
I would not be here for that, dude. I guess it's still a 3-day weekend, but the third day is Thanksgiving. Like, what? You don't... Anytime there's a 3-day weekend, the third day is always the recovery day. It's always the, like, catch up on sleep, like, you know, I'm gonna eat a lot of food on Thanksgiving. I know I will. Oh, that was bright. I actually went to 2 different grocery stores trying to find the dish I want to bring to my Friendsgiving celebration tomorrow. And finally, one of my students who I teach here in LA hit me up and said, "Hey, Dr. Gold, I actually found the thing you're looking for. It was in this obscure grocery store next to him." He said, "I picked up all the ones in there, and like you can have one of them." Dope. The item in question is the DiGiorno Thanksgiving pizza. I've been trying to get this. The wildest fan favorite. Yeah, it's a Thanksgiving pizza. It has all the things in like Thanksgiving on a pizza. It's the most American thing I've ever seen. I have to, Jesus, besides these ads, what are these ads? This is the most American thing. Green beans, crispy onions, dried cranberries, and gravy drizzle on a Detroit style crust. I am so excited for this. The Thanksgiving pizza. Yeah, it sold out last year. I could not find it this year. I went to 3 different grocery stores. I could not find this fucking pizza. But one of my students said they found it next to their house. So I'm gonna go pick it up tonight. They said they cleared it out. They saw like a couple of them and then just took all of them. What's up, Ace? Good to see you. Anyways, yep, that's Thanksgiving. Oh, we got a lot of screenshots in the chat. Looks like we got Bloxfruiter, Cristiano Ronaldo. Which Cristiano, are you Diba? Asner said you're Diba. But it's a good question you asked anyways. I think your question looks cool. And then Adarsh has some good ones. Ooh, vertices and stuff. And then Ace has some good ones on trig ratios. Nice. Love it. Okay, we got a lot of good questions. Happy Thanksgiving. Oh, no, you're okay, Dennis. Never apologize. No, I'm always thankful for any of you guys showing up at any point in time. It's very cool. You got hit with exams back to back. Yeah, all good. I hope exams are going well for you. It is very much exam season right now. And then there's like a break, and then the week after is all the final exams. So if you need help with final exams, we'll be helping you guys out during that time. Yeah. One sec. Let me make sure my sound settings are here on this sound control panel. What do they do? Levels? Oh yeah, levels are all fine. Okay, cool. Okay, let's see. First clip we got up is Bloxfruiter. Bloxfruiter, are you in the chat? Bloxfruiter? Got a good question with sequences. You're on Thanksgiving break right now. After a week of more material review, and then you have 3 on the same Monday? That's so... No, dude. No. You can usually request that to get changed. So in college, they usually always have an alternate day for the final exam. For this case, exactly. If you have 3 finals on, like, the same day, that's just cruel and unusual. Usually, if you have that, you can get one of them rescheduled for another day. But some students just want to get it over with, and I understand that. You just be like, I just want to be done with life. So, whatever you want to do. Okay, cool. Other announcements. Ooh, yes, we have an AMA guest on Friday. So come on by on Friday. It's gonna be at 6 p.m. Pacific, which is 8 p.m. Central, 9 p.m. Eastern. And we're having a yoga teacher, breathwork instructor who's going to be here live on the stream answering all your questions. So if you want to be entered in for a chance to win a $20 gift card, all you have to do is just submit a question in our Discord. So I'll show it to you real quick right here. It's right here. Here where it says like submit AMA questions. Just put down like a question you'd like to ask our guest. Here's like a little quick bio about her. She's a pretty cool person. Nice. Blockfruiter's a follower. What's up, Blockfruiter? Anyways, that'll be on Friday. So it's an AMA, which AMA stands for Ask Me Anything, which means you can literally ask whatever. And I try to do these podcasts as an opportunity for you guys as students to have the ability to just freely ask whatever out of people who have a lot more experience than you do. And without any sort of like judgment and stuff, because you all are behind like screen names and usernames and stuff. But so if you've ever had a question about yoga or breath work or even just like mental health stuff or whatnot, or you just want to ask a Swedish girl like a question, she'll be on the stream here. So please, submit questions. We use them as topics, and we'll go through them. And at the end, one of you guys will win $20 for asking a question. Okay, cool. All right. So now that we got that done, here, let's go through some of the questions today and start the stream. All right, welcome everyone to Actual Education Office Hours. My name is Dr. Gold. This is the stream that helps you out with math homework, science homework.
Nice. Perfect.
All sorts of fun stuff. Let's see. We got Bloxfruiter. What's up, Bloxfruiter? You do have a question you asked. So here, let's put your question up on the board. I find it funny that you and Cristiano Ronaldo both like submitted screenshots that look exactly the same. It's a little suspicious. But okay. How do I paste this? No, not that one. Oh, it's this one. Sorry. There we go. What's up, Sensation? How's it going? I see you in the audience. You just waking up right now? Kind of a late day? Late morning? Early morning? You said, Dennis says, I can get Switch with physics, but I don't really... Wait, I already pasted this. Excuse me? What's happening? Dude, what? Okay, this is dumb. Sorry. There you go. I don't really mind too, because I want to get home early. Yeah, I understand. That totally happens. Okay. All right. Bloxford asks, in a certain sequence, the first term is a 2, and the second term is a 5, and then each subsequent term is a sum of the 2 preceding terms multiplied by the term number. What is the 10th term in the sequence? Oh, this is kind of cool. This is kind of like computer science, honestly. A lot of computer science stuff works like this, where you're like trying to determine algorithms and things. Okay, so the first term, I usually like to write up my terms with like n's. So here, we'll say like n equals 1, n equals 2, and then so forth. We'll try to see what goes on. Okay, so the first term is 2. Is this Fibonacci Lucas? Is that what this is, Jeff? What does that mean? The second term is 5, and then each subsequent term is a sum of the 2 preceding terms multiplied by the term number. Okay, so for this one, it's equal to the sum of the 2 preceding numbers. So that's 2 plus 5 multiplied by the term number, which is 3. Yeah, except for the number thing, right? The number thing's kind of weird here. Okay. So when I see this, I like to try to represent what these things are. Okay. So this is the term number. This is n. And then this is the value, which we would call like, I guess a sub n, right, Jeff? So a sub n here is 2. And then here we have like n equals 1, n equals 2, n equals 3. Yeah. Yeah, let's do it. All right, cool. And then what we're going to do is we're going to try to like build this out, because we want to do this eventually to the 10th term, which I could just keep doing this on and on and on and on, but that would take a very long time to like keep calculating like the 4th term, then the 5th term, the 6th term, the 7th term. So we want to see if there's a pattern for this. Okay. So what I notice here with the 3rd term right here, right? It's the sum of the 1st term and the 2nd term. Okay. So let's use different colors for this. I think this is cool to use different colors. Let's make this like a 2. And then let's make this the 5. Okay. And then let's change the colors on these. And I'm going to say that this thing is 2. Okay. And then this 3 thing, this is like the term number. Okay. So let's call this... Ooh, what color do I want to use for this? Let's use gold. I like gold. Let's do this. So then this is... Ugh. This is gold. And then keep in mind, this is not dividing. I'm just saying that, like, this is the 3rd term, and then this is what it is. Okay. So it turns out that this one would eventually end up equaling... oh, and then we forgot... Jeff, we almost forgot this one. We forgot it's times the term number. So this would be 7 times 3. Which would end up being 21. Okay. So this ends up being 21. Okay. Bloxfruiter, to get credit for asking a question, I need you to at least participate a little bit in this, okay? I want you to tell me what the 4th term would be. Or at least try to describe to me what the process would be to get to the 4th term. How do we get the 4th term? Using, like, what's here. Subsequent means, like, the next term. Is what it does. Let's see. Where's Bloxfruiter? The wait music's coming on. Anyone good with organic chemistry? Anuki says he is. I've taken OChem. Teaching it is kind of painful. There you go, Bloxfruiter. Okay. Bloxfruiter, how do I figure out what the 4th term is? It's in the chat. Yeah, he's a Darsh in my Discord. Who watching? Test? No, toast. Not test. Toast. Yeah, you can post a screenshot too if you want. I can try to take a look at it if Dookie wants to. Dookie can take a stab at it. A2 plus A3 times 4. Oh, very good. Yeah, nice. Good job, Bloxfruiter. Yeah, exactly. So, yes, this one would be this term plus this term times this. Good. Yeah, very good. Very good. Very good, Blocks. Okay, so this would be 5. Plus 21, I think. Yeah, good. Yeah, I wrote the wrong thing. It's not times. It's plus. So that'd be 5. Plus 21 all times 4. Which, yeah, I mean, this is really gonna suck. Because, I mean, we're only got to the 4th term, and I gotta go do this for, like, another, like, how many of these? 5, 6, 7, 8, 9, 10? Like, we don't want to do that. All right. So, what we want to do is we want to try to, like, write things in terms of, like, n and stuff. Ugh, one sec, my vision is going. I'm gonna try drinking some water. Like, I can't see straight. I think there is a closed form here. Okay, so this right here, this is a sub n. So a sub n is equal to, it's the one before, right? So it's a sub n minus 1 plus a sub n minus 2 all times n, I think is what it is, right? Yeah, is there a closed form of this? I don't want to have to go through and do 10 of these. This like really sucks. It includes a gamma function? No, we're not gonna do that. We're not gonna do the gamma function. Okay. Let's try something else. I'm gonna try doing this using Excel. I think Excel is probably a better way to do this. And I'll show you how this works. Okay. So there might be a simpler solution. Well, let's see. Okay. So I'm gonna call this is like my term, right? What do we know? The first term was 2. The next one was 5, right? And actually here, let's do this. Term here, let me put the term number here first. And then we'll make this a sub n. And so this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Excel is very useful for doing things like this. You're okay. So the first term was... what did we say the first term was? First term was 2. Second term is 5. Okay. See, A1 is 2. This is 5. Okay, and then this is equal to... and then it's this one plus the cell behind it. And then it's all times this thing right here. Cool. And then what we can do is we can just do this. We can just drag down. So here's the cool thing. When you drag down like this on Excel, it will do the same calculation. But like shift everything down. So for instance, this one, right, did this times the blue. This one, look, does the 5 times 21, right? The two before it times the 4. And then this does this times this. And then this times this times this. This is why Excel is very useful for this. It's very good for like iterating over processes. And like you could code this actually using Python. But anyways, yeah. So we get the answer is 3642970. So I'm tempted to say this is correct. It looks pretty correct. That's what you got as well? Okay, cool. Let's see if ChatGPT can come up with something for it. I'm curious. Here we go. Solve this. Let's see what happens. I think is the like 35 something. Yeah, okay, cool. Yeah. So we're gonna get the same answer. 364,927,0. Okay, cool. So we can ask like, is there a closed form solution for this? Yeah, this is a sequence. A series, I think, is a summation, right? Sequence is the actual individual terms. Oh, okay. Dude, what? Where phi is the golden ratio? Excuse me? Dude, what? What is this thing going at? Oh, okay. Well, it involves Fibonacci numbers. Okay. So yeah, I don't think you're actually expected to solve this one in closed form. I think the way we did it here with an Excel spreadsheet is probably what you just have to do. Anyways, all right. That's a good question, Blocks. Nice. Good job, Blocks. I'll send you your V-Bucks later tonight if I remember. But yeah, good job. What's up, Equity? Let's see. Equity, you're submitting your question again. I'm glad you're back, Equity. Jesus. Wow, Jade. Man. Oh my god. This OChem. Oh god. Yeah, no, this OChem's yeah, I'm looking at what this OChem stuff coming up. Yeah. This is cool. This is where like chemistry starts becoming almost like math. But yeah, that's hard stuff. Maybe a Darsh can help you out with it. All right. Is Cristiano Ronaldo here? Looks like we got something with like cylindrical tanks. This is a differential equation, is what this is. Jeff says n plus gamma. Yeah. Okay, cool. I need my vision to come back. I started getting like kind of lightheaded, and now it's hard to focus on screens right now. This light is probably not helping. One sec. Turn this one off. Oh, okay. Eyes are a little bit better. Yeah, it was my first time donating blood, so I had no clue what was going to happen. And I'm now seeing why I don't want to donate blood. Because I can't function. Like, good cause, I guess, for people and whatnot. Your drink is sugary? No, this is just water. I probably should... I just ate a whole fucking candy bar, though, right? That should be enough sugar, right? But yeah, I'm getting this... Yeah, right? Dude, I ate like a massive like fast break. Dude, that thing's got like 100 grams of sugar in it. How long till you feel normal? I don't know. But it is interesting. I think the lights actually trigger it. Let me turn the lights off. Oh. Okay, that feels slightly better. Okay. The human body is a weird thing. Let me see. I got a Darsh up. Let me help a Darsh out. Ugh, Jesus. Okay. This is a pretty good one, a Darsh. So, this is nice, because this thing is already in what we call vertex form, which is this. Y is equal to A x minus h squared plus k, okay? Where h comma k is going to be equal to the vertex. So in this case right here, if this is our function, right? And it's already in vertex form. What is the vertex? I'm giving 100 odds to gold dying during the stream. I might have to end it early, honestly. Ugh. If it doesn't get better, because it is hurting my eyes to look at a screen right now. And it's just hard to focus. I can't focus on things. X equals -4. Yeah, yes, good. Yeah. This is minus h, so since this is plus 4, that means h is -4. Yeah, good. And then k is equal to -8, because it's plus k, but you got minus 8. Okay, cool. That's easy, right? So this is -4, comma -8. State the domain. So this is just a parabola. And parabolas, again, look something like, you know, just like nice little U's and stuff, yeah. Oh, yeah, there you are, Cristiano. Yeah, I was asking about your question. I'll do yours next. I was waiting for you to come on the stream. This specifically has a minus as the coefficient out front, so it's gonna look something like this, probably. I'm betting. It's going to point down. But the domain are the x values, which is just all of them. He dropped the C from his name. He did. Or he had a K in it at one point. Okay, yeah, so domain is going to be all real numbers. This is from negative infinity to infinity. Interval of increase. So where's the function increasing? So if this is the vertex here at -4, -8, when they talk about like increasing or decreasing, it's like as I move from the left to the right, is the function going up or down? So here I see as I go from left to right, the function is going up as I go this way. But not all the time, right? Just from here. As we go from here to here, where from like the depths of negative infinity, all the way up to the vertex, the function increases. Right, and then as it goes here, it starts decreasing. So the interval increase, you have to be careful because you can't include -4. So this has to be negative infinity. You can't include negative infinity either, but then this is -4 because technically at -4, which would be like this, it's neither increasing or decreasing. Okay. Change it to standard form. So changing it to standard form just means multiplying it out. So this would be equal to y is equal to 1/2, and that's going to be x squared plus 8x plus 16 minus 8. So again, we just took the x plus 4 here, and we expanded it out. That got us x squared plus 8x plus 16. And now we just multiply the 1/2 through. So that's going to get me 1/2 x squared plus 4x plus 8. But then we also have a minus 8. So actually, this goes away. So it's just really equal to 1/2 x squared plus 4x plus 0. It's kind of cool. There is a negative. Oh, you are so right. Thank you. Thank you for catching that. I was wrong. It's because I can't see things right now. Fuck. Okay. Negative 1/2 x squared minus 4x minus 8 minus 8. Okay, thank you. Yeah, that's better. So that's negative 1/2 x squared minus 4x minus 16. Okay, that's better. That looks like standard form. State the axis of symmetry. Axis of symmetry is always just thinking about like if I were to like put a line somewhere, what would make this kind of like a mirror image of each other, right? And that's going to be here. Here we can see that this and this are like mirror images of each other. And that occurs at x is equal to -4. So axis of symmetry is x is equal to -4. Note, there's no axis of symmetry in the horizontal direction. State the range. That's going to be negative infinity to -4, but including -4. Because start all the way down here. You can go all the way up to -4. And then find all solutions of the quadratic. Ooh. Well, interesting. So looking at this graph, Adarsh. Oh, sorry. The interval of decrease. Interval of decrease is then, that's, I forgot to answer that one, sorry. That's -4 to positive infinity. For this. The green point is 0, -4? No, the green point is -4, -8. That's the vertex, right? Based on that, Jeff? Yeah. No, you're good. So it's interesting. When it says find all solutions of the quadratic, maybe I need some sugar? Yeah, bro. Yeah, is your vision okay? My vision's coming back. I have a headache, though. Holy shit. But My vision's coming back at least. I swear the blue line was the y-axis. Yeah, no, my bad. This is the x and y-axis. I should have used a dash line for this, really. Yeah, that's just the axis of symmetry. Here we can say axis of symmetry. Correct. Yeah, I'm messing up. Thank you. Good save, Jeff. The sugar's paying off. Thanks for keeping me honest. Now, trying to find all the solutions. It's interesting. So, the solutions to the quadratic, I think they mean the roots. It's kind of weird for them to say the solutions. Dude, I love how it says there's bullying. What's the bullying? Oh, it's because of simplex pachinko. We gotta tell Obi he has to change his username because it's apparently a racial slur now. It's triggering all my bots. What's up, Sam? I actually do need to drink water. Thank you, Sam. I really do.
Just but unfortunate.
What's up?
Name.
What's up?
Pachinko is a game.
Yeah, Pachinko's a really cool game, actually.
But chinko means something else entirely.
Well, chink means something else. Yeah, I get that. But
Well, yeah, that too, but...
well, chinko means something different, too?
yeah.
Sorry, you said in Thai or what?
Japanese.
Oh, Japanese. Oh, okay.
It's like... Willy? I don't know.
Like dick?
Well, no, like Willy. I mean... like a small child would say, chinko.
Oh, here we go. It says it's a pinball game. Is it?
No,
like
it's only pinball. It's only with ball bearings because you can't use real money.
Yeah, it's
For all intents and purposes, it is illegal to use cash to gamble in Asia.
Really? Gambling is illegal in Asia?
With money.
What happens in Macau?
They don't use money,
They use marbles?
basically.
Does it get exchanged into money eventually?
Yeah, I've played pachinko, and yeah, you take massive amounts of ball bearings to a machine that gives you money.
Oh. That seems like a weird workaround. It's pretty cool, though.
It's because Asians are horrible, horrible gamblers.
Well, like they have problems with, like they're just bad at gambling, or they develop bad problems with gambling.
It's not even confined to a particular country or nation or group of people. Just Asians generally will sell their children to gamble.
Oh, okay. Okay, so they're just susceptible to gambling. Okay. I get you. That's interesting. I wonder if that ties into the whole, like, opium, like, war thing that... We kind of really fucked up China at one point, right? By, like, getting everyone addicted to opium.
That was the British that did that.
It wasn't the Americans? It was the British?
No, it was just us. We said, give us Hong Kong, and so we had it for 99 years.
Said, here, free drugs.
We should never have given back Hong Kong.
Well, you know what I find funny is that all the Hong Kong protest stuff started happening, and then what happened? Like, while it was happening?
Which one?
COVID. No, I mean the big student protests that were happening. You remember, like, Hong Kong was all in the news, and then it was like the next day it was like, oh, COVID's a big issue now, guys, and then we just forgot about Hong Kong. Yeah, distractions. Anyways, all solutions. There are no solutions to this quadratic because this quadratic has a vertex below the x-axis and it points down, so it will never cross the x-axis. You thought it was SARS? No, dude, I'm pretty sure it was COVID. Or maybe
COVID
did it happen
SARS.
as well?
COVID is SARS.
Oh, COVID is SARS. Oh.
COVID's a misnomer. The common cold is COVID.
Well, I remember the whole SARS thing was another thing at one point, no? The original old SARS. Yeah.
SARS was a big thing in 2003, but it basically never escaped China because the Chinese borders were shut tight.
Dude, let's ask ChatGPT. Let's say, like...
But I was there.
Is every time there's unrest in Hong Kong, does a pandemic happen? Just curious. Says it's likely a coincidence rather than a consistent pattern. While major certain events do align in time. Okay, here we go. Interesting. Oh, okay. Yeah, this is what I was talking about, the protests, the 2019 protests and COVID. And he's talking about, so SARS was 2002, 2003. Some students weren't even born at that point in time. And I guess, okay, there was a handover in 1997.
That's funny. I was there in 1997 and 2002.
Yeah. Interesting. Anyways, yeah, good question here, Adarsh. Nice. Yeah, nice. It's kind of fun. What were you doing in Hong Kong, dude? What? What are you doing in Hong Kong? 2002. Sensations gonna got sensations with the grammar. The spelling is like fucking spell it.
Like, the only time and place you can get away with using you in lieu of YOU is if you're Dutch. Are you Dutch? No.
Do they do that? Do they do that with the umlaut?
No. The Dutch YOU is just the letter U.
Oh, is it? Oh, I didn't know that. You're okay, Adarsh. Sensation's just trying to make us better people by causing us to spell things correctly. I support it.
We don't even have to do it poorly with texting anymore because we have bandwidth now.
All right, Cristiano Ronaldo, or as Asner says, your name is Deba. Which one is it? Although we had Sensation do a background check, and he said you guys are different people. So
seems to be.
I agree. This is a differential equations question. It's a cool calculus question, actually. Boom, boom, boom.
I like this one. This one's so stupid.
What's this meme, dude? What? Excuse me. God damn it. You're fat.
It's just so happy and it's just like a ridiculous cunt.
This seems too easy. The leak rate should be vary with the amount in the tank. Let's see. A cylindrical tank. Okay. All right. Cristiano Ronaldo. You gotta help me with this one though. You gotta help me with this. Connect one. I can count the potato too, man. Yeah, this would be more fun if this was a cone. But you know, it's kind of cool.
At least it's easier with a cone. Not with a cone.
It's easier. It's much easier with the cylinder. Yeah, this would be a lot harder with the cone. We'd have to do like some geometric identities.
Well, this is just what's the volume of a cylinder, and you're like, okay, cool.
Well, let's see. Okay, the radius here is 5. I mean, if this is too easy, we can do a harder one. Radius here is 5. And it's a height of 10 meters. And it's being filled with water at a rate of 2 cubic meters per minute. Okay, so this is 2 meters cubed per minute. But then water is leaking out of the tank at a rate of 1 cubic meter per minute. Oh, this is very easy. I mean, there's a little bit of it involved stuff here. And we want to know, how long will it take for the water level to rise to 80%? What's up, Pernille? Use Bernoulli's equation and equation of continuity? Bro, what? We don't need to get that crazy. Watts. What's up, Gold? What's up, Pernille? Sensation's gonna cause you to become a better speller. Okay, Ronaldo. I'm not gonna call you Christian because it hurts my fucking brain. Ronaldo, what do I do next? Yeah, what do I do? How do I solve this question? Thank you, Pernille. I do need to drink more water. I donated blood today, and my fucking vision has been going, but it's more or less stabilized now. We're happy. 1.21 gigawatts. Still doing office hours. Respect. Thanks, man. Well, I mean, it wasn't so bad when I started, and then I think the light started getting to me and started messing up my vision. It's better now. I just have a huge headache. Ugh, okay. Ronaldo, what do I do next? I gotta teach you. That's the whole point of this stream. Gotta... Oh, wow, look at this. Okay. He says pi 5 squared times 10 is 200... Okay, that's a good thing to figure out. I agree with that. Yeah. Yeah, so we're getting like what? We're getting like the volume of the cylinder. Okay, I like that. Yeah, volume of cylinder is equal to pi r squared times the h. Okay. So that's pi times 5 squared times 10. Which, I agree, yes, that's 250 pi meters cubed. Okay, what do we do next? Found the volume of the cylinder. Find 80%. Yeah, that's a good thing to do. Yeah, let's find 80% of it, right? So yeah, multiply by 0.8. I like that. Or I'm gonna multiply by 8/10, because I want to like turn this. I want to avoid using a calculator, and I think I can, right? Because 8/10 is the same thing as 4/5. And here's a cool little trick, right? If I got 4/5 times 250, I see that there's a 5, and there's something with a 5 here as well, right? That's kind of cool. Or, I mean, even if I really wanted to do this, right? 4 times 250, we know is just 1,000. So that's going to give us 1,000 pi. And then over 5. And then 1,000 over 5 is just 200. Okay, so 200 pi meters cubed is 80%. And pi equals 3. No, pi does not equal 3. Jeff out here trying to cause violence. Saying pi is 3. The net rate is 1 meter cubed per meter. It is. Because we have two... Yeah, so here's what we can say, like, the net rate. So, net rate is equal to rate in minus rate out. Which in this case is nice because it's constant, right? The rate in and the rate out is the same. In real life, the rates are usually not constant. Well, I guess they are with a cylinder, it's fine. But if this were a cone, for instance, the rate would actually depend on the amount of stuff that's there. It would depend on the volume. And this would become a much funner differential equation to solve. Or I guess they call it related rates. It's actually really a related rates question. Right, so we got 2 meters cubed per minute minus 1 meter cubed per minute. Yeah, exactly. So that's approximately 1 meter cubed per minute. So, all right, yeah, volume is going to equal to rate times time, which in this case is 200 pi meters cubed is equal to 1 meter cubed per minute times the time. So then we divide by 1, divide by 1. This is going to go away. And then this goes away, and then, yeah, we just have our answer. 200 pi minutes, which I think you could just leave it like this. Which, yes, in Jeffland is approximately 600 minutes, which is approximately 10 hours. Wow, nice. Good job.
Well done! Well done!
I figure out like what your account is, Ronaldo. $6.28. Yeah, it's actually not a bad one, right? Yeah, it's not bad. Nice. Okay. Cool. Good job. All right. Let's see. What do we got next? Ace up to bat next. What does it mean to be a good person, Aristotle? What does it mean, Nietzsche? What does it mean? What? Steve Austin. Stone Cold Steve Austin, dude. Is he from? I think he's from Texas. Stone Cold Steve Austin. Okay, let's see. Let's see if Ace is out in the chat. Go away, Olaf. Dun, 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 dun.
Nice!
Habib Kebab, what's up? Thanks for the follow, dog. Habib means like girlfriend? Or is that Habibi? Or you are Habibi. Habibi Kebab. It's like baby. It's like saying like baby, like my dear. So Habibi Kebab is like baby kebab. I mean, I like kebabs. I don't know if I started calling a girl a kebab though, she would like appreciate that. It's not a really endearing term. Okay. Let's see. Wait for Ace to come back until he does. Got a question from Dennis. Estimate. It means my friend or my love. Kebab is just something I added. That's cool, man. I like kebabs. I'm a big fan of kebabs. You know what I really like, actually? Oh man, what's it called? It's a Persian thing. It's called kofta kebab. Yeah. This stuff is the best, dude. I love this shit. Yeah, do you guys like this stuff? This stuff's really good. Yeah, this is the supreme kebab. This is the king of kebabs. Big fan of this stuff. They serve it a lot here. So I live in Los Angeles, and we have a big Persian community. So there's a lot of Mediterranean food like this here. Turds on a stick. They do kind of look like turds, but they taste fucking delicious, Jeff. Yeah, kebabs are great. I'm a big fan of these. You could also do kebabs with, you know, like chicken and like vegetables. Yeah, here's like a chicken kebab. Jeff is not classy. I agree. Yeah, Jeff what? Jeff doesn't know. Jeff doesn't know how good the kebabs are, dude. The kebabs are great. All right, let's see. We got a question here from Dennis. Says, estimate the subsolar point temperature for the Earth's moon. Okay. Assume the moon is 1 AU from the sun with an albedo of 0.14. 3 more weeks left of comp sci. Nice. Well, comp sci never ends because you can start coding things forever, I guess. Okay, what the hell are all these words? What is albedo and what is subsolar point temperature? Oh, reflectivity? Oh, is that what that means? Oh, that's pretty cool. I didn't know that. Okay, let's just, I'm gonna have ChatGPT teach me about this. Oh, Ace is back. Yeah, we can do yours next. Just curious. Energy balance question, considering the radiative equilibrium temperature. So this is actually, a lot of astronomy is like this. They just give you these equations. Like, this is the very classic one, which is, I think it's something like this, right? T squared goes as, like, r to the third. This talks about, like, the period of, like, orbit versus, like, the radius of the orbit. Like, a lot of these things just simplify down to cute little equations. Yeah, T squared over r to the third over, yeah, r cubed over T squared is constant. Yeah, I agree with that. So here, let's just see what all this stuff is. I'm just curious. I enjoy learning things. We are put here on this earth to learn. Okay, to estimate the subsolar, we can use an energy balance equation, which is this. Cool. Oh, so this is the reflectivity. That's cool. And then T is the temperature. So actually, here's an interesting thing. Let's... 30 streams. Hey, nice. Good job, Ace. Let's consider that... Let's say the reflectivity was 1. Okay, the albedo was 1. That would mean that the moon would just reflect all of the sunlight hitting it. Okay? Reflectivity is like how much energy gets reflected back. So if A were equal to 1... we can see that this becomes 1 minus 1, which becomes 0. And so then the temperature of the moon just becomes 0. Which kind of makes sense. I like doing this. When I see physics equations, we like to consider what are called the extreme cases. Or like the end behavior. Of like, yeah, what happens if my reflectivity was 100%? Well, then the temperature would go to 0. And that makes sense. That's what do we call that? It's consistent. It's consistent. It's consistent with what I expect. It would make the moon a white body. Yeah, maybe. Like a white dwarf. That has to do also with like the gravity, like collapsing on itself. Okay. S is the solar constant at 1 AU, which is this. Oh, this is cool. So someone was asking me, I think Ace was asking me about intensity and the sun and stuff. This is very cool. So this tells me that at a distance away from the sun, which is equal to 1 AU, which is how far the Earth is from the sun. The Earth is 1 AU, 1 astronomical unit from the sun. That the amount of energy or power, like the power density, this is kind of like the intensity, is 1361 watts per meter squared. So that means if you were to, for instance, take a piece of solar panel that was 1 meter by 1 meter, you could have effectively collect 1361 watts. Assuming like 100% efficiency in the solar panel. And also, I'm pretty sure the atmosphere steals like 30% of the energy just from coming in. Yeah, okay, good. Yeah, Jeff says by the time it gets closer to the but by the time it gets to the atmosphere, it's closer to 1,000 watts. Yeah, that's the number I remember. Yeah, it's 1 kilowatt per meter squared. Which, Dennis, have you seen this before? There's actually a really cool animation for this. So it's like size of solar panel to power the Earth. Yeah, okay, here we go. Yeah, max solar panel efficiency around 90%. Yeah. Sorry, 30%. Yeah. Yeah, okay, so this is the picture I want to look at. Okay. So this is actually even cooler. So this is again, you see how they're assuming 1,000 watts per square meter, and they also only assume 20% efficiency. And then they also say 2,000 hours per year, because what happens is, right, is that as the Earth rotates, it's not always at the peak position to receive sunlight, right? At night, it doesn't receive anything. And this is actually one of the big problems with solar, is that the collection time, so when you collect the most energy, is opposite to when you use it. Most people use electricity at night, right, for lights, for heaters and whatnot, but all the sunlight gets collected during the day. So then you get this issue of you need something to store that energy, and this is where batteries become a huge hassle because they break down. People start trying to do, like, I don't know, have you seen this? Like flywheels? Like, they take massive wheels of concrete and spin them, and then they store the energy in that. But if we were able to do this, right, this is all we would need to fill with solar panels. That's it. Just that amount of space. Which, you know, doesn't seem like that much, right? Yeah, I think they have one here where it shows, like, yeah, this is... This is, I guess, the Earth. Can I see this? Let me just get this image bigger. Yeah. Basically, we turned New Mexico into a solar panel, and we could just, like, keep the U.S. running off of solar. Yeah. The issues with this, right? Storage, and also the transmission. In order to get this energy from New Mexico to all these different places where the electricity is needed, you end up losing a bunch of energy in the transmission. Due to, like, just ohmic heating, step-down transformers. There's just a lot of problems with solar. Anyways, so back to the question here, though. But that's cool. That's when I saw this 1361. I know that this is close to a number that they make you memorize all the time in any sort of, like, physics stuff. Oh, and then this is the Stefan-Boltzmann constant. Do you know where the Stefan-Boltzmann constant comes from, Dennis? I believe this has to do with, well, it comes down to what's called, like, black body radiation, I believe is where this comes from. So let's look, like, Stefan. Yeah. So what it says is that the energy radiated over something is equal to the Stefan-Boltzmann constant times the temperature to the 4th power. Yeah, it's pretty cool. So yeah, if you look at the wavelength of all... So when something is hot, it radiates energy in the form of light. And that light is at different wavelengths. And if you were to add up all the different wavelengths in this, like, distribution, you end up getting this sigma times t to the 4th. Yeah, I attended a lecture series from visiting black body radiation. Yeah, that's very cool, Dennis. Yeah, you're getting familiar with the language. You're learning the jargon. Jeff says, even when something is cold. Yeah, for sure. Even when something is cold, it radiates some amount of... And, like, cold is a subjective term, right? Cold is just the absence of heat. Technically, everything has heat. But being cold just means it doesn't have as much heat. But anyways, yeah, that's where that comes from. And this looks like, yeah, you just plug it in. And so what they get there is that the subsolar temperature is approximately 379 degrees Kelvin, which for those in the stream that don't know what this weird Kelvin thing is, you just always minus 273 to get this in centigrade. So this ends up equaling, what is this, 106 centigrade? Which is approximately, I would say, what is that 212 Fahrenheit, basically, because this is almost 100 degrees Fahrenheit, 100 degrees centigrade. So it's like boiling. Wow. So the subsolar temperature of the moon is enough to boil water? That's pretty cool. I was doing it somewhere. What was I doing here? Yeah, I could say, like, is that hot enough to boil water? Yeah, yeah, oh, yeah. But I like how ChatGPT puts this little condition here of like, yes, but to boil water at that temperature, it needs to be at atmospheric pressure, which on the moon, there's no atmospheric pressure, so it wouldn't really work. Yeah, it wouldn't boil it. It wouldn't boil it under, yeah. On the moon, there is no atmosphere, so the water would... Oh, so the water boils at a much lower temperature. Oh, yeah. So that's actually cool. So water can boil as low as 0 degrees centigrade. Oh, wow. That's very cool. Well, no. Yeah, it does. It does contradict itself here. So the 379 is hot enough to boil water. It is hot enough to boil water under atmospheric, but it's not hot enough to boil it on the moon. Oh, yeah, the triple point. Yeah, the triple point's cool. Yeah. Anyways, that's a cool question, Dennis. I appreciated that. It was fun. Fun to learn some stuff. Yeah, 379 is greater than 273. Yeah, I know, they're wrong. Want to hear the inside of my brain? Yes. Oh, dear. What am I going to listen to here, Sensation Dude? This is apparently the inside of Sensation's brain. What the hell? What the hell am I listening to here, Sensation? Tell me this is something in Japanese at least. Anyways, okay. Okay, what's up, Ace? Here, Ace, you want to do your question? I never said I was sane. I never assumed you were either. Okay, what's up, Ace? Okay, cool. Says, determine the exact primary trigonometric ratio for each angle. Okay. This is cool. So, this requires finding what's called the reference angle. Okay. Where the reference angle is always... So, for instance, if you go around in like a bunch of different angles like this, right? The reference angle is always taking wherever this point is. They call it the terminal point, and connecting it to this axis. And then this is your angle. Okay. So, for instance, if we have negative 45 degrees, negative means we go clockwise versus counterclockwise. So, we're going to go counterclockwise, 45 degrees. And then we're going to connect this to the axis. And now we have a triangle. These are what I call the special right triangles, which there's only really two you need to know. So you have what's called the 30, 60, 90, which I always make my hypotenuse 1. So this is 1, square root of 3 over 2, 1/2. Yeah, good. And then... So yeah, you can do 1 root 2. I generally don't like doing that. I always like the hypotenuse to be 1. So I would say 1 square root of 2 over 2, square root of 2 over 2. This is the same thing as 1 root 2. You're just dividing everything by root 2. Yeah, if you take all the sides and divide all the sides of a triangle by the same number, it's the same thing. Okay. So if this is 45 degrees, right? That matches this triangle. And so you end up just like writing what all the things are. So this is 1. If this is below the axis, you say this is like negative root 2 over 2. And because this is to the right of the y-axis, this is positive root 2 over 2. And then it's very easy to just do sine, cosine, tangent. Because it's either opposite of or adjacent, you know, I don't know, adjacent over hypotenuse or opposite over hypotenuse. You just figure it out. Let's see one that would be harder. I kind of like this, oh, 540, no. Yeah, I like this negative 120. Let's look at negative 120 real quick, because there is some trickiness to here, to negative 120. Okay. So negative 120, again, go in the reverse direction. So instead of going this way 120, we're going to go this way 120 degrees. Okay. Which, if this is now the coterminal point, you need to have it line up with this. So that this is now your reference triangle. Now, looking at the triangle, I want to know what this angle is. Which I know going the whole thing would be 180. So this small amount here, good, is just 60. Yeah, good job, Ace. Yeah, nice.
Nice.
Not 69, but 60. This looks like this triangle, the 30, 60, 90. Where we know opposite the 60, we have square root of 3 over 2. But that one is negative. And then the other angle is going to be 1/2. And that's also going to be negative. And then the hypotenuse is always already 1. So now you have, right, your adjacent, you have your opposite, you have your hypotenuse. And you can calculate all the trig ratios from there. Cool. All right, that's a good question, Ace. Nice. Yeah, so that's a weird one. So that's a 180 is what that is. So negative 540 is going around 360 and then another 180. So let's see. If we were to do this and we went around this would be going around 360 and then you have to go around another 180. So it ends up just being this. Is equal to 540 degrees. And then these have all the weird things where like some of these are 0, some of these are undefined. Because basically what happens when you get to this this type of triangle is that the hypotenuse is equal to 1, the opposite is equal to 0, and the adjacent is equal to negative 1 when you're here. Yeah. Okay. One sec. Let me take a quick, like, 2-minute break. I gotta get more water so I can still see. And then we'll come back and do more questions. Okay? Cool. Alright, let me go do that. One sec. I'll put the break music on for you guys.
Dr. Gold in the lab, Twitch stream glowing, formulas flashing, minds wide, knowledge flowing, equations on the board, numbers never sleep, teaching math and physics while them haters count sheep. Actual education, tune in and get schooled, flipping textbooks, breaking all the rules, from Newton to Einstein, concepts elevate. Keep the stream, it's the key to our fate. Dr. Gold dropping gems, knowledge raining down. Actual education making scholars all around. Perpendicular minds, angles sharp as ice. Maths and physics, yeah, the future's real nice. Got the Pythagorean triangles about to flex. Quantum theories on deck, breaking all the specs. Relativity theories, worlds getting small. Grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep. Grazing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold. Brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down. Actual education making scholars all around. Perpendicular minds, angles sharp as ice. Maths and physics, yeah, the future's real nice.
All right, nice. We're back. I went and got some Advil. Also, my head is killing me right now. I don't know if I'm ever donating blood again. Like, I get the whole, it's nice, it's charitable, like, do good things for people, but it's impeding my ability to help you guys with math and science. Oh, man. My body does not like losing fluids, I guess. Okay. Let's see. What's up with equities? Equity back? Bob Ross's. I need a nap. Or I will also kind of look at, let's look at this OChem question that Jade threw up. What the hell is this? Active methylene compounds are of great importance to synthetic chemistry when methylene is flanked by two electron withdrawing groups. Okay. Is flanked. Then its hydrogen becomes acidic and can be replaced easily. The acidity of methylene hydrogen depends on the strength of the electron withdrawn. Wow, okay. Acetoacetic? What's acetoacetic? What? Is that double COOHs, dude? What? Oh, man. Okay. Let's see. CH3CO CH2COOET. And I guess ET is the ethylene, is what it is? What's up? Hey, what's up, Laz? Good to see you, Laz. Hope your Thanksgiving week's going well. I'm curious about this. I want to see what we're gonna have. We're gonna have ChatGPT teach me some OChem today. ChatGPT is actually surprisingly good at chemistry. My underdamped oscillation model isn't, though. Oh, man. Yeah, are you doing stuff with, like, damped, critically damped, and whatnot? That's actually, you know, that's actually a cool... I like that stuff better. One sec. Overdamped. Yeah, it has to do with this, right? Yeah, so light damp. So anytime you have like a wave, right? Usually the wave experiences some sort of opposing force. And that can be like friction, or that can be heat. Like something, the energy is getting lost somehow, you know? And so the amplitude of your wave decreases over time. A cool example of this would be, for instance, like a pendulum moving back and forth. Eventually, over time, there's friction between, like, the axle and, like, what the thing is, and also you have air resistance. And so that robs energy from the oscillation to then decrease it from, like, going so far up the next time. There's actually a very famous video on this one. What is it? It's the man... It's, like, physics teacher... drops pendulum, like doesn't hit his face or something. Yeah, this one. This is always fun.
You're sitting at home alone.
Picture this. You need a therapist. If she was my therapist, I would totally hire her. Anyways, yeah, this guy's from... Oh, this is cool. I think this guy's from MIT.
And I can lift it up 1 meter, 15 tons.
But it's a very, very... So he has
You can demolish a building.
a pendulum.
You just let it hit.
that goes back and forth and whatnot. And he does this cool thing where he drops it right from his chin. And the neat thing here is that as the thing swings and comes back, it won't go higher than what it started. So even though it's right there by his chin, look, watch it. It doesn't hit it again. Just super close. Ah! If he pushed any bit on it, though, it would.
And I'm still alive.
But yeah, those are cool. Those are like little lab demonstrations they do in physics classes. Okay. All right. If we don't have any more questions for today, I'll end the stream a little early, mainly because I have a headache from donating blood today, and I wanted to at least answer as many questions as I could today, but I need to take a little bit of a break. So, all right. Without further ado, let's close out the stream. All right. Thank you, everyone, for coming to office hours today. Appreciate you guys asking questions right before Thanksgiving break coming up. So we are gonna have a special AMA podcast guest on for Friday. So please come on by and make sure to submit your questions. Submit some questions for our guest, please, in the Discord. It's there, and we'll go through it. It'll be fun. But that'll be at 6 p.m. Pacific, 8 p.m. Central, 9 p.m. Eastern. So come on by for that. Yeah, sorry, I could. Yeah, my head is hurting. But let's go say hi to Penn Center. Penn Center is a good friend of ours. So again, yeah, if you found us through whatever, YouTube, TikTok, there's a lot of other really cool math streamers out there. Here they are. They're great. And then there is the calendar for all their events. So we're gonna go say hi to Penn Center because we love Penn Center. He's our friend from Canada. So yeah. So come on by Friday. Have a wonderful rest of your day. Have a wonderful Thanksgiving tomorrow. I hope tomorrow's full of like lots of nice food and friends and stuff. It's one of my favorite holidays. Yeah, you're very welcome, Equity. Okay. All right. Let's go say hi to Penn Center, and we will see you guys on Friday. Peace out.